Hi, this is Alex from devstories.eu, Mastering DeepChem, episode 10 of 15. If you were screening molecules for a new drug, maybe 1 in 10,000 actually works. A model that just predicts every molecule is useless will achieve a 99.99% accuracy rate while discovering absolutely nothing. This is why basic accuracy is often a terrible measure for scientific discovery, and it is exactly why we need to talk about evaluating scientific models. In the sciences, data sets are almost always highly imbalanced. Consider building a classifier to predict HIV inhibition. The vast majority of tested chemical compounds will not inhibit the virus. The active drug candidates are extremely rare. If you use standard accuracy to evaluate your model, the results will lie to you. The model simply learns to guess the majority class, scoring very high numbers while completely failing to find a single working drug. To fix this, you need metrics that expose this behavior. The first is the recall score. Recall measures how many of the actual active compounds your model successfully identified. It strictly punishes models that miss true discoveries. However, recall alone is not a complete picture. A naive model could just guess that every single compound is active, achieving a perfect recall score while generating thousands of false positives. This is where the Matthews correlation coefficient, or MCC, becomes essential. MCC is a balanced measure that evaluates all 4 categories of your results. It looks at true positives, true negatives, false positives, and false negatives simultaneously. It produces a score between -1 and +1. A score of +1 means perfect prediction, 0 means the model is no better than random guessing, and -1 means total disagreement. MCC only generates a high score if the model predicts accurately on both the rare active compounds and the common inactive ones. It brutally penalizes a model that takes the easy route of guessing the majority class. You might wonder why you cannot just import these exact metric functions directly from scikit-learn. Scikit-learn has perfectly good implementations of both recall and MCC. The issue comes down to the data shape. DeepChem models frequently perform multitask learning, predicting dozens of different chemical properties simultaneously. Standard scikit-learn functions expect simple, flat arrays. If you pass them DeepChem's complex multi-dimensional outputs, they will either crash or calculate the score incorrectly. DeepChem solves this mismatch with its own metric class. This class acts as a wrapper around standard mathematical scoring functions. When you instantiate a DeepChem metric, you pass it the raw scoring function you want to use, like the MCC function from scikit-learn. The metric wrapper takes over from there. It manages the batching of your data and aligns the true labels with your model predictions across the entire dataset. Here is the key insight. The metric class relies heavily on an internal mechanism called normalized prediction shape. It inspects your data to determine if your model is outputting a single task, multiple tasks, or one hot encoded probability vectors. It then reshapes those raw multidimensional outputs into the exact flat arrays that the underlying mathematical functions require. You don't have to write manual loops to slice and unpack your multitask arrays before scoring them. The wrapper handles the structural complexity automatically, so the math works exactly as intended. When you evaluate a scientific model on an imbalanced dataset, your primary job is to prove that the model is not cheating the baseline, so choose a metric that forces the model to actually learn the rare chemistry. Thanks for spending a few minutes with me. Until next time, take it easy.